In this tutorial, we're going to take a look at converting from standard form to factored form, and specifically with some fractions. There's no fractions for these coefficients, but I guess I could have done that. You're going to find that one of the x-intercepts is going to be a fraction, a rational number, and then also the coordinates of the vertex will end up being similar, the similar fractions. So the first thing that we want to do is we want to factor this to put it in factored form. So there's lots of ways to factor a trinomial. I'm going to use the method that most people call decomposition, but there are other ways as well, of course. So we want to find two numbers with a sum of -2 from the -2x and with a product of -24, because 3 times -8 is -24. And so the numbers that there's the 3 times -8. The numbers that do that would be -6 and +4. They add to -2, and they have a product of -24. So we use that -6 and 4 to decompose, that's why this is called decomposition, the -2x into -6x plus 4x. That adds to -2x, that's why this is an equivalent form of this. And so now we're going to factor by grouping. So we can factor a 3x, and that's what this is called factoring by grouping. We can factor a 3x out of these two terms. So you factor the first two and the last two. And so if we factor a 3x out of 3x squared, we get x. If we factor a 3x out of a -6x, we get -2. Remember, you're just dividing. So we're actually dividing this by 3x to get that x, dividing that by 3x to get the -2. And on the end here, the 4x minus 8, there's a common factor of 4. 4 divides into both of these, so we factor a 4 out of a 4x, we get x. We factor a 4 out of -8, we get -2. Remember, these always have to be the same. That's a clue that you're doing this correctly. If they're not, then something happened. Maybe you got the wrong numbers here or something, or you factored incorrectly. So x minus 2 is the common factor here, so we can factor this into x minus 2, and after the x minus 2 factors out, what's left is 3x plus 4, that's the other factor. Now I'm going to show two ways to find what the roots are. Okay, so this isn't completely true factored form. It's in a factored form, but factored form actually looks a little bit differently, I guess. Now I'm going to change it so I have the 3x at the beginning and the x minus 2 in the end. That's going to make this step a little bit more convenient, so there's no real other reason I've done that. I just switched the order of the two factors. So this is the true factored form. It's a, x minus r, x minus s. Some people use p and q here instead of r and s. So we need to factor this 3 out. And 3 doesn't factor out evenly out of 4. So I'm going to show a way to do this. One way to do this. There's more than one way to do this. So what I'm going to do is I'm going to multiply this by 3 over 3. Now 3 over 3 is the same as multiplying by 1. If you multiply something by 1, it doesn't change its value at all. It stays the same. It's just going to change to a different form. So here's my 3 over 3. And again, this is equivalent to this because that is equal to 1. Now, 3 over 3 is the same as 3 times a third. See, this actually has, if you want to write it, a denominator of 1 here. So this 3 times this 1 is this 3. 1 times 3 in the denominator is that 3. Okay, so those are equivalent forms. So I'm going to change this 3 over 3 into 3 times a third. That's equivalent. And what I'm going to do is I'm going to multiply the 1/3 into this first set of brackets. So if I multiply, so we'll leave the 3 outside and multiply by a third. When I multiply a third by 3x, I get 3x over 3. See, remember this 3x, actually, if you want to write it, has a denominator of 1. So 1 times 3x is this 3x. In the denominator, 3 times 1 is this 3. When I multiply the 1/3 by 4, the 4 has also a denominator of 1. So 1 times 4 is 4 in the numerator. 3 times the 1 is 3 in the denominator. So the 3x over 3 here, that's the same as x because those 3's actually divide out. 3 divided by 3 is 1. So that's actually the same as x there. So y equals 3 and then brackets x plus 4/3, x minus 2. That's actually true factored form. Now, I said I was going to show you how to do this in two ways. This really, I mean, if you want to write in true factored form, that's the way you can do that. That's the way you can factor that 3 out. There is another way to find what the intercepts are. So what we could do is take these two factors and set them each equal to 0. So if I set 3x plus 4 equal to 0, I'll subtract 4 from both sides to remove the 4 from the left side, or get the constant on the right side. So that's 0, so this is negative 4, so 3x equals negative 4. And then if we divide both sides by 3, to isolate the x, see again 3x over 3, just like down here, that's equal to x. So we get x equals negative 4/3. If we set the x minus 2 factor to 0 and add 2 to both sides to get the 2, the constant on the right side again, that's 0 there, so we just have x equals 2. So 2 and negative 4/3 are the two intercepts. Now, we'll continue with this on the next page here. If you had just done this, then we would set each of these equal to 0 and isolate for x. You will get the same two roots. That's what we're going to do in the next page. So if you had stayed with this true factored form, if you set each of the factors equal to 0, x plus 4/3 equals 0. So if I subtract 4/3 from both sides, I get x equals negative 4/3. If I add 2 to both sides, it's exactly the same I did in the last page. I get x equals 2. So if you had worked with the true factored form, then there's the same two roots. So we use the x equals r plus s over 2 to find the axis of symmetry. So we can find where the vertex is. So and r and s would be these negative 4/3 and 2. So negative 4/3 and 2 are the r and s values. Now in order to add these, the 2 is a whole number, but the negative 4/3 is a rational number, or a fraction. So I'm going to multiply that 2 by 3 over 3 to get a common denominator. So the 2 becomes, multiplying by 3 over 3, 6/3. 2 is the same as 6/3. So if I add these together, negative 4/3 and 6/3 adds to 2/3. See, negative 4 plus 6 is 2. So that's the 2/3. This 2 is the 2 in the denominator here. Now, that 2, in order to simplify this, that 2 is the same as 2 over 1. So what I'm going to do is I'm going to take the 2/3 in the numerator and multiply it by the reciprocal of the 2 over 1, which is 1 over 2. And so let's go back to the pen here. If we multiply that, 2 times 1 is 2, 3 times 2 is 6, and then that will reduce. So we can divide both those by 2. We'll get rid of that. And so we get 1/3. So x equals 1/3 is the axis of symmetry. So now 1/3, see, here's 0, here's 1. So it's 1/3 of the way across. That would be 1/3, this would be 2/3, and that would be 3/3 or 1. So there's the axis of symmetry. The vertex is on that somewhere. We need to find the y-coordinate of the vertex. So we find the y-coordinate of the vertex by substituting that 1/3 into our equation. And so we can use this version or the standard form version. I'm going to use the standard form version. And so we substitute a third in here in place of x. Remember, if you have a fraction button on your calculator function, you can make this step a little bit more convenient. If you want to just do it like old school, we need to square the 1/3. So 1 squared is 1, 3 squared is 9 in the denominator. The 2 times a third. Remember that 2 is the same as 2 over 1. So negative 2 times 1 is the negative 2. 1 times 3 is 3 in the denominator. And I'm multiplying the negative 8 by 3/3 because that's going to be my common denominator. This already has the denominator of 3. And when I multiply the 3, maybe I'll do this separately here. See, 3 times the 9th, so I'm kind of looking ahead here a bit. 3 times 1 is 3. And in the denominator, 1 times 9 is 9. And I can divide both those by 3, so that will actually simplify to 1/3. So that's a third minus the 2/3, and negative 8 times 3 is negative 24. There's a 1 here in the denominator. 1 times 3 is 3, so notice I have the same denominator for all these. So 1 minus 2 is negative 1, minus 24 is negative 25 thirds, so that's the y-coordinate of the vertex. So the vertex's exact coordinates would be 1/3 for x, negative 25/3 for y. So now I could write that as negative 8 1/3. See, 3 goes into 25 8 times, with 1 left over to make the 25. So it's negative 8 1/3. So the vertex could be written as 1/3 comma negative 8/3. If you want to change it to decimals, it might be easier for graphing. See, 1 divided by 3 to 1 decimal place is 0.3. It's actually 0.3 repeating. And this would be negative 8.3 repeating, so we'll round to negative 8.3. So this is minus 5, so over 1/3, or 0.3. 6, 7, see, that's 8. And then 1/3 the way from here to here. So about right there would be where the vertex is. Now the step pattern for y equals x squared, the untransformed regular quadratic, is 1, 3, 5. So since a is 3 here, for this standard form or factor form, doesn't matter which, we multiply the 1, 3, 5 by 3 to get 3, 9, 15. So from here we would go over 1 and up 3. From here we would go over 1, up 3. And then next we do 9. So from here we'll go over 1 and up 9. From here, over 1 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the up 9. I can't really show the up 15 because it's off the top of the graph. So, but that's enough. We get 5 points. We can draw our parabola. So that's what y equals 3x squared minus 2x minus 8, or this factored form version, would look like. And that's how you deal with the fractions if they come up. And that's the end of the tutorial.